welcome to the 2011 number 2 solution. So let's take a look. We have a political party registration by gender of 500 registered voters in Franklin Township. When I see a contingency table like this, my first thought is they're probably going to have me do independent, which as we read further, we're going to find out that's true in this case as well. So here, let's get right to it. I know this is going to be like a probability and an independence type of question. So given that a randomly selected registered voter is a male, what's the probability that he is registered for party Y? So there's key things you got to look for, like when it says given here, that's a big tip off for me. So given that it's a male, so we're only looking at the male category, which is the 200 people. Then what's the probability that he is registered for party Y? So here's party Y of the males, because it's given that he's a male already. I can ignore the rest of the table and look at only the male row. So 48 out of 200 is what we're going to be doing. All right. And that's it for part A. Let me look at the solution real quick. You can see right here, of the 200 males, 48 are in party Y. So you just do 48 over 200 to get your 0.24. So this is all you really need to do, maybe a little context, but really I think they'll be okay with just an answer like that on that one. That's just a quick one. Okay, part B, among the registered voters of Franklin, so that's everybody, you got 500. Are the events male and registered for party Y independent? So we're looking for independence now. That's your keyword. Oh, independence. Okay, I got to check it. Now they tell you here, justify your answer based on the probabilities calculated from the table above. So up here, but I'm also like a lot of times they set you up for the independence by giving you a probability to start with. So we've already done 48 out of 200. So the easiest check is to just take the total right under the 48 here, take that 168 and go the same direction. So 48 out of 200 should equal 168 out of 500 if they truly are independent. So I'm going to take my 168 over 500 and check to see if that's the same probability as the 48 out of 200. If this table is truly independent, then 120 out of 300 should be the same as 48 out of 200, which should be the same as 168 out of 500. Like these little conditional ones, probabilities, should match the total probability. And that would go for X and W, right? And you can also go the other way. So 60 out of 88 should equal 300 out of 500 if this is truly independent. Right? Same thing, like 120 out of 244 should equal 300 out of 500. Now, we're going to find out on this one that when you do this, like let's look at the answer real quick. So on part B, you can see here, we did the 0.24 from above, and notice they're doing this probability notation. I love it. So party Y, given that it's a male, 0.24, that comes from the previous question. And then we added in one little more piece. So what's the probability of being in party Y to begin with? Well, that's 160 out of 500 like we thought, right? 168 out of the 500. So we can see these probabilities are different. So that's what they're going to talk about here. Because those are not the same, the two events are not independent. Okay, they have to be the same if they're independent. But it didn't, like, let's say these were the same. Unfortunately, that doesn't tell you they're independent to begin with, because this is only one situation. You would actually have to go, like, if this probability matches this one, I would have to continue to check all the possibilities, 120 over 300 and 124 over 200 and 244 to 500 should all be the same. 60 over 300, 28 over 200, and 88 over 500 should all be the same. So you would have to check them all in order to prove that it's independent, because they all have to work. They all have to be the same probabilities if it truly is independent. So if you find one that doesn't fit, then you're done. You can just stop, which is what we have in this case. You know, they're not independent because these are not the same. You're done. But if these were the same, you'd have to continue. And a lot of times people just write the probability right in the table. Like they'll do the percentage here and here and here and show that they're the same. probability here, 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 show that they're the same, etc. Right? And you can just fill that in the table. And then when you're writing up your stuff, you can just refer to it. Say, see the probabilities in the table. You can see that for any column, they're the same, right? Or any row, they're the same. You don't have to do both ways. Just either do all the column directions or do all the row directions or column directions. You wouldn't have to do both directions, just one direction. Okay, let's look at part C. Part C, one way to display the data on the table is to use a segmented bar graph, which you see down here. The following segmented bar graph constructed from the data in the party registration for Franklin Township, this is Franklin, shows party registration distributions for males and females. So distribution, here we have a distribution for males and females. And we can see the good thing about this segmented bar graph is that we can see immediately that these percentages are not the same. If these were independent, these would exactly line up. This bar and this bar would exactly line up, and these would exactly line up to make them independent. All right. So if we keep going here, so we got Lawrence Township, so different city. Sorry, I got to move down now. The proportions of all registered voters, W, X, and Y, are the same as for Franklin. So same as for Franklin. And party registration is independent. So it's the same parties, but in this case, they're telling us that they would be independent. So complete the graph below to show the distributions of party registration by gender in Lawrence Township. So it's still 500. It's still WXY. In fact, I'm not sure it's 500. They didn't tell. It doesn't matter. It's the percentages that we care about. You can see down here, it's all in proportion down here. So what proportion should we be using? We should be using the marginal proportions that we have. So for party W, whoops, I've got to go up here. So we're going to use these marginal proportions. For party W, 88 out of 500 is your that's like your total, right? So like you don't want to use the little conditional ones. We want to use the total because this is kind of your baseline. 88 out of 500, I would use that percentage, and then down here I would mark that percentage in, and I would make them the same in both graphs, right? 88 out of 500. And then I would take my 244 out of 500, get that percentage, and then add that on to the previous one and make that mark. And in both male and female, it'd be exactly the same because they're independent. And then your 168 out of 500 to finish it off should kind of make that a total of 100%, right? This plus this plus this total should equal 500. And that should also be represented down here in nice equal bars for the male and female. Well, you're just going to have 2 bars, right? Okay, so that would be it. That would be the end of the problem. So let's look at the solution. You can see that they took those 3 marginal probabilities and found what those percentages were. Those obviously add up to 100%, right? And then those, like I said before, those are your baselines. Those are what all the conditional little probabilities of each cell should be following if it really is independent. So they went ahead and they graphed that out up here. And you can see that, like, I don't know what it is. What did they say? Did they come up? Yeah, like it's like 18% almost. So there's 18% here for the first one. The second one is 49%. So if you take your 18 plus another 49, you'll get up in here, right? 67 or whatever. So they put those bars. You'll see they're equal for males and females because they told us that it is independent. So we have to create it to be independent with it the same. And that's it. Thank you very much.